Today I will be telling you a little about quadrilaterals. So we know that the prefix of a quadrilateral is quad, meaning four. So, so by definition, a quadrilateral is a shape that has four sides, four angles, and four vertices. On the right, there are a few images of what a quadrilateral looks like. Quadrilaterals can be subdivided into other groups based on the properties of quadrilaterals. The main subdivision is between concave and convex. A concave quadrilateral is a quadrilateral that has an interior angle larger than 180 degrees, and a convex quadrilateral is a quadrilateral that has an interior angle less than 180 degrees. Here to the left, it shows you a convex polygon and how all the angles are less than 180 degrees. To the right, it shows you a concave polygon that how at least one of the angles is greater than 180 degrees. We're going to go more into depth on convex quadrilaterals. One convex quadrilateral is a trapezoid, and a trapezoid, by definition, is a quadrilateral that has exactly one pair of parallel sides. If you look to the right, there's an image, and on the image you can see that segment AB is parallel to segment CD. Another type of convex quadrilateral is a parallelogram. A parallelogram is a quadrilateral with two pairs of parallel sides. If you look to the right, you can see an example of a parallelogram. We're going to go more into depth on a parallelogram. One type of parallelogram is a rectangle. A rectangle is when opposite sides are parallel and it has four right angles. Now, if we have a parallelogram where we don't necessarily have four right angles, but where we do have the length of sides being equal, then we have a rhombus, which is the second picture on the right. Lastly, we have a square that has four right angles and where all sides are equal lengths. I will go more in depth on the square in a second. Some notes to remember are all rhombi are parallelograms, all rectangles are parallelograms, all parallelograms you cannot assume to be rectangles, and all parallelograms you cannot assume to be rhombi. Here on the slide we have a Venn diagram between a rectangle, square, and a rhombus. Here, this Venn diagram is telling us how all squares are both rhombi and rectangles and parallelograms. But not all rectangles are squares, not all rhombi are squares, and not all parallelograms are squares. Those are some important